Hello students, in this video we are going to learn the concept of the large sample test, specifically the Z test for a single mean. So before we'll start with this particular testing of hypothesis, firstly we need to understand that what is the procedure we are going to adopt for the same. So even in this particular part also we are going to use the terminologies. We have already made one video for the same. You can go through that one so that you can understand the basic terminologies whatever we are going to use here. Okay, so in the problem of testing of hypothesis we are going to follow certain steps. So in the form of procedure I have written here. The first step is we need to set up the null and alternate hypothesis. So like I told you, that null hypothesis which is denoted by H0. Now because in this particular part we are going to perform Z test for a single mean, so in this case we in every problem we are given some value of the population means, and we need to test about that particular value only. Okay, so our null hypothesis will be mu is equal to mu naught. Okay, generally in the simple hypothesis we are assuming that mu is equal to mu naught, but sometime we are given mu is less than or equal to mu naught, means sometime we are given the composite hypothesis also. So in most of the cases our H naught will be mu equal to mu naught, and we need to test the alternate hypothesis against this is either mu is not equal to mu naught, or mu is greater than mu naught, or mu is less than mu naught, right? Which is the alternate hypothesis. It is a two-tailed alternative. This is a one-tail alternative or right-tail alternative, or this is a one-tail and left-tail alternative. That particular thing again we have discussed in our last video where we have discussed the basic terminologies. Now the next step is we need to choose the appropriate level of significance. So level of significance, generally we choose the value of alpha as 1% or 5% level of significance, right? And the next step is we need to compute the test statistic. So what is the formula for the same? The formula is same which we have studied in the central limit theorem also. So it is a statistic, like generally to measure the population means we are using the statistic as a sample mean. So our test statistic T is x bar, and we know that sample mean is the unbiased estimator of population mean. So expectation of x bar is mu, and the variance of x bar is equal to sigma square upon n, right? So we are going to use all these terminologies to calculate the test statistics. So the formula of Z comes out to be x bar minus mu upon sigma upon square root of n. So in the problem of the large sample test, because in this particular part we are concentrating on large sample test. So large sample test means it is given in the problem that we are going to follow the data follow normal distribution only. So generally we are given a problem where the sample size is greater than or equal to 30. This is the condition of the large sample. Okay, and the another thing is in this case either the population standard deviation is given, sigma is known, or it is unknown. Okay, or it is unknown, sigma is unknown. So if the sigma is known, then we can use the test statistic as this one, z equal to x bar minus mu upon sigma upon square root of n. And if it is unknown, so we are going to use x bar minus mu upon sigma upon square root of n. If sigma is known, means if the population standard deviation is known, then we are going to use this formula. But if it is unknown, then we can use the sample standard deviation in place of the population standard deviation if sigma is unknown. Okay, because although we know that the expectation of S square, its value, it comes out to be n minus 1 upon n times sigma square, or it is 1 minus 1 upon n times sigma square. Okay, so when n is very large, we are assuming n tends to infinity, then expectation of s square is approximately equal to sigma square only. So it means that if the sample size is large, then sample variance is the unbiased estimator of population variance. So we can replace sigma with small s if sigma is unknown. So this is the formula we are going to use as a test statistic. Okay, and another thing, like we have discussed, that the formula of z is t minus expectation of t upon standard error. This standard deviation is also called the standard error. Standard error. Standard error of x bar. Okay, so sometime the question asks that what is the standard error for this particular estimate. So the standard error is sigma upon square root of n if sigma is known, and if it is unknown, then we can use s upon square root of n. Okay, so this is the test statistic we are going to use in the problem of the large sample test for single mean. Okay, now let us see that how can we use this particular criteria in the problem. And what is the last part? Last part is we are going to conclude the result. So we are going to compare the value of test statistics with the critical value. The critical value which we have already discussed in our last video. So the last step is we are going to compare this calculated value of test statistics with the critical value at the given of level of significance. Say if we are choosing 1% level of significance for two tail tests, its value is 2.58. So we want to see that either the value of z falls in between minus 2.58 to 2.58, or it falls outside this particular interval. According to that, we are going to accept or reject the null hypothesis, right? So in this case, minus 2.58 and 2.58, this is the region of rejection, and this is the region of acceptance. If the value falls within this, that means the value falls in the acceptance region, and if the value is less than 2.58, minus 2.58 or greater than 2.58, in that case this is the value falls in the critical region, or this is the rejection region only. So on the basis of that only we are going to either accept or reject the null hypothesis. Okay, so let us start with the problem. Okay, so suppose in this problem the question is a sample of 900 members has a mean 3.4 centimeter. So we have taken a sample. What is the sample size? 900. So in this case we are given sample size means n is given here 900, has a mean because it is a sample mean, so it is denoted by x bar. Sample mean is given here 3.4 centimeter, and a standard deviation 2.61 centimeter. So we are given the sample standard deviation as 2.61 centimeter. Is the sample taken from a large population of mean 3.25 centimeter? So we want to test that either the sample has been drawn from a population whose mean, population mean means mu is given here 3.25 centimeter, and the population standard deviation is given as 2.61 centimeter. Okay, this is the first question, that can we say that this sample has been drawn from the population whose mean is this and standard deviation is this. Second part is, if the population is normal and its mean is unknown, find the 95% and 98% fiducial limit of true mean. Okay, so basically there are two questions in this case. One is we want to test that either this sample has been drawn from the population whose mean is 3.25, means I want to test that either the difference in these two value is a significant or insignificant, right? Okay, so what is the step we need to follow? Like this is the procedure we have discussed. Firstly, we need to set up null and alternate hypothesis. So what will be the null hypothesis for the same? Null hypothesis means no change. So in this case we are assuming that yes, the sample has been drawn from the population whose mean is 3.25 centimeter only. Okay, So this is our null hypothesis. What about alternate hypothesis? Alternate hypothesis is no, this sample has been drawn from the population whose mean is not equal to 3.25. Okay, means we are going to test here two-tailed alternative. Two-tailed alternative. Two-tailed alternative means this is the normal curve. So we are going to consider these two and as a two-tailed test. So next step is what is the level of significance. Level of significance, because in this case the question is asked for two different limit, so we can choose any one of them. Generally we are choosing alpha equal to 5%, right? Generally we are choosing alpha equal to 5%. 5% means two tail test means 2.5% rejecting from this side and 2.5% rejecting from this side. And in two tail test, if alpha equal to 5%, in case of two tail test, the value of Z alpha is 1.96, means the value of mode of Z alpha is 1.96, means here the critical value is from minus 1.96 to 1.96. What does it mean? Means if the value falls between these two value, this is the acceptance region and this is the rejection region. This is the rejection region. Okay, means if the value falls in between these 2 points, then we are going to accept the null hypothesis. If the value falls outside this particular range, means the value less than minus 1.96 or greater than 1.96, we are going to reject the null hypothesis. Okay, so now the next step is we are going to calculate the test statistic. So this is step number 1. We need to set up null hypothesis. This is step number 2. Choose the level of significance. Third step is test statistic we need to calculate. So what is Z? X bar minus mu. I told you if sigma is known, then we are going to use this formula. Okay, if sigma is unknown, then we can use sample standard deviation in case of population is not given. Okay, but in this case both are same, so but because population standard deviation is given, so we are going to use the formula sigma upon square root of n only, right? So x bar is given here 3.4, mu is given here 3.25, sigma is given here 2.61, and divided by square root of n is given here square root of 900. So if I solve this particular part, its value is 0.15 upon 2.61 multiply square root of 900 is 30. So if we calculate this, its value is 4.5 divided by 2.61. Okay, so if we use the calculator, then 4.5 divided by 2.61, its value comes out to be 1.72. okay, let me check again. So basically 3.4 minus 3.25 multiply by 30 divided by 2.61. So its value is 1.724. So its value comes out to be 1.724. So what do we find out here? This is the calculated value of Z. So Z calculated comes out to be 1.724, and the value of mode Z is 1.96. So clearly 1.724 falls within the acceptance region, because this value is slightly smaller than 1.96 but greater than minus 1.96. okay, so because Z calculated is less than mode of Z calculated less than mode of Z alpha, that is 1.96, means the value falls in a acceptance region. Value falls in the acceptance region. Acceptance region. So it means that null hypothesis accepted. Null hypothesis accepted. So null hypothesis accepted means yes, this sample has been drawn from a population whose mean is 3.25, means there is not significance difference between the sample mean and population means. Okay, so the difference is only due to the fluctuation of sampling only. So it means that yes, the sample has been drawn from the population, of mean 3.25 and standard deviation 2.61 only. This is the first part of the answer. Okay, now come to the second part. Second part is we want to find out the 95% and 98% fiducial limit. So what is the meaning of that? Means we are going to calculate the value of mu from this particular part. So we are assuming that what is the value of mu if the value falls in the acceptance region, when the level of significance we are considering 95%. okay, so what does it mean? Let me add one blank slide. Okay, so it means that I'm going to assume that mode of Z alpha is less than or equal to x minus mu upon sigma upon square root of n, right? Not, it is not greater than, it is less than or equal to, basically it is less than or equal to mod of Z alpha. Okay, so what is the confidence? If I say that 95% confidence limit, it means that 95% is the acceptance region. So what is the region of rejection? 5%. So what is alpha? Alpha is 5%, means basically alpha is 5%, means we are going to consider alpha by 2. So from this particular expression we need to find out the value of mu. Okay, so what is Z alpha at 5%? Its value is 1.96. so x bar minus mu upon, if population mean is unknown, okay, if the standard deviation is unknown, then we can replace it with sample standard deviation, but it is given here, then we can use it. So this is basically minus 1.96 less than or equal to x bar minus mu upon sigma upon square root of n less than or equal to 1.96. so multiply negative sign or sigma by square root of n, minus 1.96 sigma upon square root of n less than or equal to x bar minus mu 1.96 into sigma upon square root of n, multiply with the negative sign. When we multiply negative sign, then the sign of inequality will change. 1.96 sigma upon square root of n greater than or equal to mu minus x bar greater than or equal to minus 1.96 sigma upon square root of n, and now adding x bar. So what do we get? X bar plus 1.96 sigma upon square root of n greater than or equal to mu greater than or equal to x bar minus 1.96 sigma upon square root of n. So I have derived this formula, otherwise the 100 into 1 minus alpha percent confidence limit its formula is x bar plus minus z alpha sigma upon square root of n, or x bar plus minus z alpha s upon square root of n. Whatever the parameter value is given here, we can substitute here. That will gives us the value of the population means. That means the mu belongs to this particular interval. So this is the direct formula I have derived here. So like x bar is known to us, it is 3.4. so this is the lower limit, this is the upper limit. So I can write 3 mu belongs to interval 3.4 plus minus 1.96 time 2.61 upon square root of n, means square root of 900. So if we solve this, this is 3.4 plus minus 1.96 into 2.61 upon 30. So if we solve this, 1.96 multiply 2.61 divided by 30. Okay, so its value is 3.4 plus minus 0.170. so I can consider 0.17 only. So it means when we add, that will gives us upper limit 3.57, and when we subtract, that will gives us the lower limit 3.23. so this is the confidence limit at 95%. Similarly for 98% means 1% from each side. So 1% from each side means 2.33. 2% means 1% from left hand side, 1% from right hand side, right? Because we are given here that when we exclude 1% from this side, its value is 2.33, and 1% when we exclude from this side, its value is plus 2.33. okay, so what is the formula for 1%? So for 1% confidence limit, or sorry, 98% confidence limit is mu belongs to x bar plus minus z alpha, that is 2.33 sigma upon square root of n. So that is 3.4 plus minus 2.33 2.61 upon 30. So if we solve this, 3.4 no 2.33 multiply by 2.61 divided by 30. So its value is 3.4 plus minus 0.2027. So if we add, that will gives us 3.6027, and if we subtract, then this is 3.1973. so this is the confidence limit for 98%. okay, so 98% means it will increase the, it will wider the interval, right? So 95% means it will narrow your interval, confidence interval, right? So you can see here its value is 3.19 to 3.60. For 95% it is 3.23 to 3.57. okay, now let us consider the another problem. Another question is, okay, so in this question, a question is, an insurance agent has claimed that the average age of a policy holders who insure through him is less than the average for all agent, which is 30.5 years. A random sample of 100 policy holders who had insured through him gave the following age distribution. Use the data to test his claim at 5% level of significance. So in this question, it is given here the insurance agent claim is that average age of policy holders who insure through his age is less than the average age for all other agent, which is 30.5. So what is the null hypothesis? So null hypothesis means no change, means his claim is that the average age of his insure policy holder is less than 30.5 years, but what we assume that no change. So we are assuming that the age of the insurance policy holders are 30.5 only. But what is his claim? So we want to test against the alternative hypothesis as H1 is that the age is less than 30.5. Less than 30.5 means this is a one tail, that is a left tail test. Okay, and it is given here the level of significance alpha is 5%. This is the level of significance. Level of significance. So for 5% level of significance, what is the value of Z alpha? So it is, because at 5% its value is minus 1.645. so we can refer the table for 5%. okay, left tail its value is minus 1.645, right? So its value is minus 1.645. what does it mean? In this case we are going to apply the left tail test. So this is the left tail test. 5% means this is the region of rejection. This is the region of rejection, and what is the critical value? Minus 1.645, means if the value is less than this one, we are going to reject the null hypothesis, and if the value is greater than this one, then we are going to accept the null hypothesis. okay, now in this case, apart from the mean, population mean, we are not given the sample mean or population standard deviation. okay, so because population standard deviation is not given, then we are going to use the second formula, x bar minus mu s upon square root of n. But firstly we need to calculate x bar and s. So we are given a data here. So data of 100 policy holders are given, that their age between 16 to 20, how many persons are there. So basically this is the frequency we are given here, and this is the interval we are given here. Firstly we need to calculate xi. Xi is the midpoint, sum of these two divided by 2. So 16 plus 20, 36 by 2 is 18. This is 23. This is 28. This is 33, and this is 38. okay, so what is the formula of sample mean? So firstly we need to calculate sample mean x bar. This is summation xi fi upon summation fi, because we need to refer the frequency distribution. Or what can we do? So we can calculate the xi minus a, let it be yi equal to xi minus a, because I am subtracting 28 from there, so it is xi minus a 28. So its value is minus 10 for simplification purpose. So minus 5, 0, 5 and 10. okay, so this can also be written as a plus summation of yi fi upon summation fi, right? okay, because I have shifted the origin. Like what is expectation of xi? This is expectation of this is yi plus a. It is expectation of yi plus expectation of constant is constant, right? So we can use this formula. okay, so we can calculate their product. So x yi fi, so we take the product. This is minus 120, this is minus 110, this is 0, this is 165, this is 380. okay, so if we sum up, this is 545 minus 230. So it is 315. So it is 28 plus 315 divided by summation fi is 100 only. Okay, let me check. So 12 into minus 10, 22 into minus 5, 30 okay, 30 into 5 is 150. There's a calculation mistake here, let me correct this. We need to take product of this into this. 30 into 5 is 150 and 16 into 10 is 160. So basically this is 310 minus 230. 310 minus 230, its value comes out to be 80. So 80 by 100, its value is 28 plus 0.80 is 28.80. So this is the value of x bar, right? So for S square, that is the sample variance, we need to use the formula 1 upon n summation xi fi xi square upon summation fi minus x bar square, right? So we are going to calculate, because variance is independent of shifting of origin. Variance of xi is same as variance of yi minus a. This is equal to variance of yi. Okay, because variance is independent of shifting of origin, so this is same as 1 upon n summation fi yi square minus y bar square or x bar square. Just value is 0.80 only. Okay, so we can calculate its square. So if we use let us calculate this with the help of Excel formula. It will reduce some computation work. Okay, I'm considering x here as 18, 23, 28, 33, 38, and the corresponding frequency f is given here. So 12, 22, 20, 30 and 16, right? Okay, so I have calculated y as x minus 28. So I'm going to simply subtract 28 from this observation and simply take this sum, and now I'm going to calculate f into y. This is equal to this multiply by this. So if we, and now I'm going to take y square equal to square of this number. 10 square is 100, 5 square is 25, 10 square is 100, right? So we are going to take here f into y square, right? Means we are going to take the product of frequency with y square. So we are taking the formula of sum. Sum of this column, control shift down, and if we drag this, right, so let us consider this in a box. Okay, so what is the formula of variance here? So variance is summation f5 y square divided by 100 minus y bar square. Y bar is 0.8, this divided by 100 bracket, it's a square. Right, so what is the formula we have used here? Let me write here. Yeah, so its value comes out to be 1 upon 100. Its value comes out to be 4100, and y bar comes out to be this one, 80 by 100, that is 0.8 square. So its value is 41 minus 0.64, so answer comes out to be 40.36. This is the value of s square, right? So x bar is known, s square is known. So what is the test statistics here? So we are going to calculate the test statistic here as test statistic z is equal to x bar minus mu s upon square root of n. X bar we have calculated 28.8, mu is 30.5, s is square root of 40.36, square root of 40.36, and n is 100, so divided by square root of 100. So this is equal to minus 1.7 multiplied by 10, because square root of 100 is 10, divided by square root of 40.36. So this is minus 17 upon, if we calculate the square root of 40.36, 40.36, it comes out to be 1.345. Sorry, we need to calculate square root. 40.36, its root is 6.353, and if we take its reciprocal and multiply by 17, then its value comes out to be 2.6 minus 2.67. and if you can see here, the value of test statistic z alpha, that is the critical value, is minus 1.645. so minus 1.645 is the critical value, and the calculated value of z is minus 2.67 something, right? It is minus 2.67. so definitely this value is smaller than this value, means definitely this value falls in the region of rejection. This value falls in the region of rejection. So because this value is smaller than z alpha, that is minus 1.645, it means that z calculated falls in a rejection region, falls in a critical region or the rejection region. Hence null hypothesis rejected. Hence null hypothesis rejected. So what can we conclude from here? It means that the claim of the insurance agent is, that is, null hypothesis is rejected, so alternate hypothesis accepted. So what is the alternate hypothesis? That is, the average age of the policy holder is less than 30.5 years. So it means that his claim is correct. It implies that the claim of insurance agent claim of the insurance agent that the average life, so average age of the policyholder is less than 30.5 years is correct. Okay, means there is no evidence that will support here that the average age of the insurance agent is not less than 30.5 years. So it means that his claim is correct. Okay, so in this case, although we are using the same thing, the only difference here is instead of the value of sample mean and the sample standard deviation, we are given a data. So with the help of data, we need to firstly calculate the sample mean and sample standard deviation, and as part is the same step: null hypothesis, alternate hypothesis, level of significance, critical value, calculate the test statistics, and then simply compare that either its value falls in the acceptance region or rejection region. Okay, let us try the next problem here. Okay, the next problem is the mean muscular endurance score of a random sample of 60 subjects was found to be 145 with a standard deviation of 40. So this is the sample size, random sample of 60, so it means n is 60, and its mean muscular endurance means the sample mean is given here 145 and the standard deviation is given here 40. So the question is construct a 95% confidence interval for the true mean. Okay, so in this case the question is directly confidence interval, so we have already discussed the formula. So 95% confidence interval, so what is the formula for the same? It is x bar plus minus z alpha. S is not given, so S upon sigma is not given, so we are using sample standard deviation, that is S upon square root of n. So what is Z alpha? So 95% means alpha is 5%, means 1.96. okay, so its value is x bar is 145 plus minus 1.96 into 40 upon square root of 60. So if we calculate this value, 1.96 multiply 40 divided by a square root of 60, its value comes out to be 10.1213. so 10.1213. So if we add, that will gives us the upper limit, means 155.1213, and if we subtract, then this is 134.8787. okay, so approximately 134.88 to 155.12. This is the 95% confidence interval. This is the first part of the question. Okay, so if 95% means 95% is the acceptance region, so 5% is the region of rejection, means 2.5% left hand side, 2.5% right hand side, so it means the middle 95% is the confidence interval. This is the region of acceptance. We want to calculate this one. Okay, now the further is, assume the sample size to be large enough for the normal population. What size of sample is required to estimate the mean within 5 of the true mean with the 95% confidence? Okay, so the question is, what size of sample is required, means I want to find out the value of n to estimate the mean within 5 of the true mean. We want to estimate the mean within 5 of the true mean, and this probability is 95%. Okay, 95% confidence means the probability is 95% that the value of the sample mean and the estimated means, that the estimated mean within 5 of the true means. So it means this value difference is falls within 5 unit. But we know that probability of x bar minus mu upon sigma upon square root of n, that is z, is less than or equal to 1.96. This probability is also 0.95, right? That the value of z falls within this interval means its value is from minus 1.96 to 1.96. Its probability is also 1.96. So this is z. What is z? Z is x bar minus mu upon sigma upon square root of n, right? So this is z. So from here I can take x bar minus mu on one side and 1.96 sigma upon square root of n equal to 0.95. So because these two expressions are same, right hand side probability is same, so these two should also be same. So if I compare 1.96, sigma is not given here, so I can replace it with s. So what is s? S is given here as a 40 equal to 0.5 times square root of n. Its value is 5. We are comparing these two values. Okay, so if we solve this expression, so square root of n is equal to 1.96 into 40 divided by 5. 5 1 the 5 8 ka, 8 1 the 8, 8 9 ka 72, 8 6 ka 48. So its value is 15.68. So this is the value of square root of n. So what is the value of n? 15.68 square. So if we take the square of 15.68, okay, let me calculate. 1.96 multiplied by 8 is right. So if I square this number, it is 245.86, means approximately 246, because n should be a integral value. So it means that the value of n is near about 246. So this should be the sample size such that the true value falls within a 5 of the estimated mean value. Okay, so whenever you are given this kind of question, so you can use this particular formula. Okay, so whatever the error is given here, you need to compare it with 1.96 s upon square root of n if it is the 95%, or z alpha. So basically the formula is, when you are given this kind of problem, so you need to simply compare E with z alpha s upon square root of n. So what is the value of square root of n? Z alpha s upon E, error, or you simply scale this one, that will give you this sample size. Okay, so these are some problems we have considered. These are the different type of problem that could be framed from the z test for single mean. Now let us discuss some MCQ type problems based on this part. Okay, the question is, if the standard deviation of the population is 50 and the sample size is 16, then the standard deviation of sampling distribution is. Standard deviation of sampling distribution is also called a standard error. So what is the standard error? It is the sampling distribution of the estimator. So if we are considering the population sample size is this one, so we know that it is sigma upon square root of n. So sigma is 50, n is square root of 16, so 50 upon 4, it is 4 1 the 4, 10 4 2 ka 8, then 4 2, so answer is 12.25. So like we have discussed the topic about the sample mean. So standard error is the standard deviation of estimator, that is x bar, and we have discussed that it is sigma upon square root of n only. Sigma is given here 50 standard deviation of population is sigma, and the sample size n is given here 16. So by substituting this value we can get the answer. Okay, let us try the next one. A sample size is considered large in which of the following cases? Like I told you, sample size is large means n should be greater than or equal to 30. In the very first slide I think we have discussed here that this large sample means the sample size should be greater than or equal to 30 only. Okay, this is the most appropriate option. Obviously if it is more than 50, again it is considered as a large test, but this is the most appropriate one. Even if it is less than 50 we can consider, right? So that's the reason the correct answer is option A. Okay, the next question is, it is known that the population standard deviation in waiting time for a new gas connection in a particular town is 20 days. Population standard deviation is sigma is given here 20 days. How large a sample should be chosen to 95% confidence that the average waiting time is within 3 days of the true average? So average minus mu is less than 3, this is 0.95, and we have already discussed that x bar minus mu upon sigma upon square root of n, this is less than or equal to 1.96 is equal to 0.95, right? Probability z mod is less than equal to 1.96 is 95% probability. Okay, so if I compare this, what can we get? Probability of x bar minus mu is less than or equal to 1.96 sigma upon square root of n equal to 0.95. So on comparing these two, so what do we get? 1.96 sigma is given here 20 upon square root of n is equal to 3. So square root of n is equal to 1.96 into 20 divided by 3. So we can calculate this. 1.96 multiply by 20 divided by 3, and then we take the square of this number. So it is approximately 171, sorry, 1.96 multiply by 20 divided by 3 is square. Okay, so its value is, because its value comes out to be 13 only, so it means the value of n comes out to be 170 point something, so approximately 171 we can say. So I think that there is a discrepancy in the options, so none of the option is correct here. So actually the correct answer should be 171, right? So this is the procedure. Basically we need to calculate the value of n with the help of this particular formula. Okay, so these are some different type of the problem that could be considered from this particular topic. So you can revise this topic. If you still find out any doubt, then you can post your query in the comment box. I'll try to provide you the solution for the same. Thank you and have a nice day.